Alright, what's going on? In this video, we're going to look at derivatives of polynomials and exponential functions. You're going to get some rules for derivatives. If you watched the last video, we used the definition to find the derivative. We used the limit. Remember, limit of f of x plus h minus f of x over h. All that divided by h, and we took the limit as h goes to 0. So this video is going to be a lot easier to find these derivatives. It's not going to be as much work. So let's go ahead and get started. So we've got our rules here. So the first one, we've got the derivative of c. C is a constant. It's a number. Anytime you take the derivative of a constant term, that's 0. I'm gonna skip this one for now. I'll come back to it. Let's see. This one's the derivative of a constant function times a constant times a function. That's just the constant times the derivative of the function. And then this property and this property, if you're taking the derivative and you have several terms, whether they're added or subtracted together, this is just telling you to take the derivative of each term. And then here we've got the derivative of e to the x. It's just e to the x. Now this one right here, this is a power rule. So it says that the derivative of x to the n is any real number, is n times x to the n minus 1. So if you have x raised to a number, okay, so x is raised to a number, the number comes down in front, and then you subtract 1 from the exponent. And that's all it is right there. Okay, it's that easy. All right, so let's look at some examples. All right, so we got quite a few examples, but I mean they're easy. So we've got f prime of x. So we've got x to a power. Remember, that's our formula. That's the key to it. X raised to a power. That's what you want. That's the only thing you know how to take the derivative of. So you've got to have x to a power, and that'll be a little more important as we go. So f prime of x, the 6 comes down in front, subtract 1 from the exponent. There's your answer. Let's look at the next one. Y equals 1,000 times x, subtract 1, that's 999. There's your answer. And then see, we got some here that's in a different variable. Y equals t to the 4th. Well, that's just y prime. The 4 comes down, subtract 1 from the exponent. There's your answer. This one just means take the derivative of r cubed. Take the derivative with respect to r. And so that's going to be what? 3r squared. The 3 comes down, subtract 1 from the exponent. So those first 4, those are real easy. Exponent comes down, subtract 1 from the exponent. All right, now this one. All right, so remember, the only thing we know how to take the derivative of is x raised to a power. Okay, that's what we've got, x raised to a power. We've got x raised to a power, but it's in the denominator. That's the problem. Okay, that's the problem. It's in the denominator. So what we've got to do is we've got to rewrite this thing so we have x raised to a power. So I'm going to rewrite my function first. So remember, if you bring something across the fraction bar, it changes the sign of the exponent. All right, anytime you move something across the fraction bar, it changes the sign of the exponent. So now we can take the derivative because I have x to a power. And so the exponent comes down, that's -2, and then subtract 1 from the exponent. -2 minus 1 is -3. And so this is going to give me -2 over x cubed. And there's your answer. All right, let's look at the next one. So once again, remember what we said. Remember what I said. it's got to be x to a power. That's the only thing that should be on your mind. X to a power. I don't have x to a power. I've got the cube root of x to a power. So let's see if I can rewrite this thing. Well, remember, this is what? X to the 2/3. Remember that property in college algebra, a to the m over n? Well, let's write it like this. The nth root of a to the m is equal to a to the m over n, converting from radical form to exponential form. And so now I have y prime is equal to, and then that's going to be what? 2/3 x, subtract 1 from the exponent, so that's going to be what? Negative 1/3, and so that's going to be 2 over 3x to the 1/3, and there's your answer. I just moved it down to the denominator to make the exponent positive. Now, you know, I don't know what your teacher wants. If they may want this 3 times, that don't really look good, but 3 times, and then we've got the cube root of x. Now, you know, either way, if you're in my class, I don't care if you leave it like this or leave it like this. All right. Now, as far as rationalizing the denominator, I don't know. You know, just whatever your teacher tells you to do, you know. It doesn't, you know, my class, I don't care. And you know, and some teachers may just say, hey, leave it like this. Just depends on, you know, depends on what teachers you have. So all 3 of them are correct. All right. So now we know how to take derivatives. So you can see, look at this. We've worked through 6 problems, okay? And it didn't take us very long to do this. If you watched the previous video, just working through 1 problem took a long time to do, okay? Because it was just a mess, you know, having to take the limit of all that. So, you know, it's going to get easier now taking these derivatives. This is the power rule. The next section you'll learn, not in this video, but the next video, you'll start learning product, quotient rule, chain rule, all that good stuff. Okay, but this is important. You've got to get this. You get this, and then you get product, quotient, chain rule, and you understand how to do that. It's going to make derivatives a whole lot easier. Okay. All right. So here they want us to find the equations of the tangent line and the normal line to the curve y equals x times square root of x at the point 1, 1. All right. So I get y equals x square root of x. All right. So what we have to do here is we've got to take the derivative, right? So to find the slope of the tangent line, okay, this was you should have learned all about this in that chapter on limits. All right, chapter on limits. So the derivative, it's a rate of change. So if we take the derivative, okay, we take the derivative and we evaluate the derivative at this point, okay, evaluate at this point, that gives you the slope of the tangent line at that point. All right, so let's take the derivative of this. Well, look at what we got. This is x times square root of x. We don't have a formula that looks anything like that. Well, you got to rewrite it. So this is going to be x times x to the 1/2, which equals x to the 3/2. X raised to the 3/2. Okay, so I just changed the square root to a 1/2 power, and then remember, when you're multiplying like bases, you add the exponents. 1 plus 1/2 is 3/2. All right, so that's our function, y equals x to the 3/2. This is the same thing as x to the 3/2. So now let's take the derivative of this. So that's going to be 3/2 times x, and then subtract 1 from the exponent, x to the 1/2. And I mean, you can leave it like that. That's fine. So now we're ready to find the slope. Okay, so we're going to find the slope of the tangent line. So that is just the first derivative evaluated at the point. Well, I only have an x value here, so I'm just going to plug in the 1 here. I know they're both 1s, but I'm plugging the 1 for the x value. I'm plugging this one in, okay, because it's the x value. So y prime of 1, that's 3/2 times 1 to the 1/2, which is just 3/2. All right, so they're asking us to find the equations of the tangent line and the normal line. All right, so what I found here, okay, so let's do this. M tan is equal to 3/2. So I put a subscript tan to let me know that's the slope of the tangent line. Okay, I've got two separate problems here. Find the equation of the tangent line, and then the next problem, find the equation of the normal line. All right, so now the slope of the normal line, and I'm going to put a subscript NORM, and this is the slope of the normal line. So remember, the slope of the normal line is the negative reciprocal. So that would be -2/3. So just to give you a picture, now look, I have no idea what the graph of this looks like, but just to get an idea, now this graph that I'm drawing, this is not the graph. This is not the graph of our function. This is just a graph of a parabola. All right, here's our point. That's the tangent line. Okay, that's the tangent line. The normal line is this line right here. It's perpendicular to the tangent line. So this is the tangent line, and this is the normal line. All right, so the normal line is perpendicular to the tangent line. So do you remember lines that are perpendicular, their slopes are negative reciprocals of each other? All right, so we've got the slope. We've got the slope of the tangent line. The slope of the tangent line, you find that by evaluating the derivative at the point. That gives you the slope of the tangent line. And then the slope of the normal line is the negative reciprocal of that. Okay, and like I said, this graph is not this. Okay, this right, I just drew that so you can see what it looks like, what's going on. All right, so now let's find the equation of the tangent line. So let's just write tangent line. We'll do that one first. All right, so remember, we're going to use y minus y1 equals m times x minus x1, point slope form of a line. So this one is going to go in for x1, and this one is going to go in for y1, and then we'll plug the slope in. So I get y minus 1 equals 3/2 times x minus 1. So y minus 1 is 3/2 x minus 3/2. So y minus 1 is 3/2 x, and that's going to be 3/2 plus 1, negative 3/2 plus 1. It's going to be positive 1/2. Whoop. Wow. And so there's the equation of your tangent line. All right. Now the equation of the normal line. So let's just do that here. Normal line. So once again, y minus y1 equals m times x minus x1. So that's y minus 1 equals m. Now in this case, m is -2/3. -2/3 times x minus 1. So y minus 1 equals -2/3 x plus 2/3. And then I add 1 to both sides. That's -2/3 x, and that's going to be, what is that? Is that 5/3? I believe that's it. All right. And there's the equation of your normal line. And remember, slopes are negative reciprocals of each other. There's the slope. Remember, the slope's the number in front of x. Those are negative reciprocals of each other. So there's your equations. Tangent line, normal line. All right. So see, this stuff isn't all that bad when you've got these rules to take derivatives. You know, I mean, it's easy. I mean, how hard is that? I mean, this over here is just algebra. Okay. All right. So now let's look at some more finding the derivative. So, so this time we have a number in front, but you know that's no big deal. So we've got y prime is equal to, so the 4 comes down. Okay, just like always, 4 comes down. Well, what's 4 times 3? That's 12. Subtract 1 from the exponent. There's your derivative. All right, what about this one? Y prime is what? That's negative 1. All right, now, if you don't see where that came from, just hold off for a minute, okay? Let's work through this one, and then I'm going to go into a little more detail about finding the derivative of where it's just an x, okay? I'll do a little more on that. Now, this one, y prime, all right, so for this one, this is just taking the derivative of each term. That's all we're doing, finding the derivative of each term. So the 8 comes down, subtract 1 from the exponent. All right, then take the derivative of the next term. The 5 comes down, that's 60x to the 4th. 5 comes down, subtract 1 from the exponent, minus, and then the 4 comes down. 4 times 4 is 16, subtract 1 from the exponent. The next one, 3 comes down, that's 30, subtract 1 from the exponent. And then this one's minus 6, that's the derivative of minus 6x is minus 6. And then the derivative of 5, which is a constant, that's 0. So there's your derivative. All right. So what I want to do now is I want to look at this a little more, show you what's going on. You probably already know, but I want to show you anyway. All right. So let's suppose I have something like this, y equals 8x. So let me show you how it's just the number in front. So this is an exponent of 1, right? You see that? So the 1 comes down. So 1 times 8 is 8. Subtract 1 from the exponent, so that's x to the 0. And so then I get y prime equals 8 times, and then remember, anything raised to the 0 power is 1. So x to the 0 is 1. So I just get y prime is 8. So whenever you're taking the derivative of a constant times x to the first, it's just that constant. And see, you can show that with a is just any real number. Well, instead of a, let's use c. C is any real number. Okay, so I've got y prime. This is to the first. 1 times c is c. That's x. Subtract 1, 0. And so y prime is c times x to the 0 is 1. And so y prime is c. See that? And so that's where this came from, this negative 1, because isn't that understood to be negative 1x? So your derivative is negative 1. All right? So I hope all this is making sense. All right. All right, so let's look at this one. Find the points on the curve y equals x to the 4th minus 6x squared plus 4, where the tangent line is horizontal. All right, so let's look at that. And let's talk about it for a minute of what we've got to do to solve this. And let's not memorize how to do all this stuff. Let's understand what we're doing. All right, think through this thing. Find the points on the curve, on this curve, where the tangent line is horizontal. So we've got a horizontal line, okay? Tangent line's horizontal. So you remember when you studied horizontal and vertical lines, okay, when you was learning about slopes and everything in algebra. The slope of a horizontal line, so the slope of a horizontal line is, let me write that out, is 0, right? That's the slope of a horizontal line, is 0. All right. So if we take the derivative of this, that's going to be what? 4x cubed minus 12x, and then the derivative of 4 is 0. Okay, so hopefully you understand how I got that derivative. All right. Now we want to know what points, okay? What points on here is the tangent line horizontal? So the slope is 0, right? So what that's telling me is I need to know what x values do I need to plug into here so that I get 0 as an answer, right? Because if I have a point over here, okay, whatever these are, this xy point, okay, whatever point I have there, if I want to know the slope of the tangent line at this point, I would take this x value and plug it in, right? But what I want to know is, what does this x value need to be so that when I plug it in, I get 0 as an answer, because I need my slope to be 0, right? Because I want a tangent line to be horizontal, so the slope has to be 0. So I'm going to take 4x cubed minus 12x and set it equal to 0. So that's going to be 4x times x squared minus 3 equals 0. And so I get x equals 0, and I get x squared equals 3x equal, and don't forget, plus or minus the square root of 3. All right, so this is where it's 0. At x values of 0, square root of 3, and negative square root of 3. So what are the points? All right, so y of 0 when x is 0, right? So that's going to be 0 to the 4th minus 6 times 0 squared plus 4 equals 4. And so at the point 0, 4, there's one point where the tangent line is 0. All right, because if we have the x value, we want to know the point, right? So we need the xy coordinate. So if I've got the x value, how do I find the y value? Well, there's y, so I got to plug the x value in to get the y value. Okay. Students get, I don't know why, but they get confused with that all the time. Oh, which one do I plug it into? Do I plug it into this one or this one? Well, what are you looking for? You're looking for the y value. Where's y? It's right there. All right. So now I've got y of negative square root of 3 is negative square root of 3 to the 4th minus 6 times negative square root of 3 squared plus 4. And that's going to give me what? Negative 5. Yeah, because that's going to be 9 minus 18 is negative 9 plus 4 is negative 5. And look, I mean, I can do this one, the positive one, but I don't need to, because I know it's the same thing as when I plugged in negative square root of 3, right? I know that's negative 5 because I'm raising it to the 4th and squared, so regardless if it's a negative or positive, it's going to be the same thing, because a negative to the 4th and a negative squared is positive. And so my other points are negative square root of 3, negative 5, and square root of 3, negative 5. And so there's the points where the tangent line is horizontal. And look, if you want to go and check this out, graph that function and you'll see there'll be like a maximum and a minimum value there. It'll come down. It'll, like, for the, I mean, I don't know if they're maximum or minimums, but it'll look like this, and you'll have a tangent line like that, or it'll be opening down like that, and you'll have tangent lines. Okay, that's what they're talking about. It would be at a point like this, is what those points would look like. See, so you can have that horizontal tangent line. You'll learn a lot more about that when you get into graphing functions and stuff in calculus. You'll learn a lot more about all this stuff. But that's what you got to do. And you see how we thought through this thing? Okay, we're not memorizing how to work anything. We're thinking through this. We're thinking about this sensibly. Okay? What are they asking? Well, I understand what all this means. My slope has to be 0, so I got to set the derivative equal to 0. Okay, you see how we thought through that? All right, so here they want us to find the second derivative of f. So I've got f prime of x is equal to, well, what's the derivative of e to the x? Well, we learned that at the very first of the video. Let's go back up. It's been about almost 27 minutes since we looked at that. The derivative of e to the x is e to the x, right? That's easy enough to remember. Derivative of e to the x is e to the x. So let's come down here. So derivative of e to the x is just e to the x minus, and then derivative of x is 1. So there's your first derivative. Now let's find the second derivative. So we just take the derivative of this thing. So derivative of e to the x is e to the x, and then derivative minus 1 is 0. So there's your second derivative. All right, so all of this easy enough for you? All right, so let's look at this. At what point on the curve y equals e to the x is the tangent line parallel to the line y equals 2x? All right, so this is easy enough, and let's think through it. Let's sketch a graph. So, I mean, this right here should be pretty easy for you to. Let's do this 1, 2, 1. So the graph of 2x, we'd have a point here, and then we'd have a point here. So that's the line y equals 2x, and then let's see, 0, 1, 1, and then that's going to be up there like that somewhere. So the graph of e to the x is going to look something like that. And you know, I don't know exactly where that point is, but somewhere like there, there's a tangent line that's parallel to this line. Okay, this is your tangent line, and it's parallel to this line here, y equals 2x. So what does it mean? What does it mean when it says that the lines are parallel? Now remember, we talked about this earlier with perpendicular lines. If two lines are perpendicular, their slopes are negative reciprocals of each other. Well, if two lines are parallel, then their slopes are the same, right? So the slope, what's the slope of this line? Well, the slope is what? 2. Remember, y equals mx plus b. Okay, the slope's the number in front of x, so the slope's 2. So we need the slope of the tangent line to be 2. Okay, the slope of the line tangent to this curve, we need it to be 2. And what we're trying to do is we're trying to find the coordinates of that point there. That's what we're looking for. Well, that's kind of like the one we did, where we wanted to know the points where the tangent line was horizontal, the slope needed to be 0, right? Well, in this problem, the slope needs to be what? It needs to be 2. All right, so I've got y equals e to the x. So y prime is e to the x. All right. So what do I need to know? Well, I need to know when does e to the x equal 2. Now, I know you may think this is stupid me showing you this, but I want you to understand that the e to the x that I'm setting equal to 2 is not this one. It's this one. I've realized that they're the same, okay? But when you're taking derivatives, it's not going to always be the same thing, okay? I'm setting this e to the x equal to 0. You set the equal to 2. You set the derivative equal to 2, right? Because I need to know what number can I plug in here for x to get 2 as an answer. See, this is my derivative. I need my slope to be 2. What does that x value need to be? So now we solve it. So remember, you just take the natural log of both sides. And so this is x equal natural log of 2. All right. So that's my x value. Now, I don't know, some of you may be sitting there looking at the screen. How did you get x? What happened over here? Well, remember that property. When these are the same, the base here and the base of the log are the same, your answer is your exponent. Well, remember, natural log, I'm going to write all this out for you so you can see it. Remember, natural log is log base e, and since those are the same, your answer is just x. All right, just to refresh your memory there. So what point is that? Well, that's what? That's natural log 2. And then what do I need? I need my y value. All right. Now, this is another one. It's not this 2. Okay, it's not that 2. I mean, the answer's 2. The answer's 2. But how am I finding it? I'm plugging natural log into here. I got to plug natural log 2 in this one to get y. So I've got y of natural log 2 is equal to e to the natural log 2, and that is just equal to 2. And so there's the point. At that point, the tangent line is parallel to that line. Okay, so here's another one. You might be wondering, well, how did you get 2? Okay, there's another property that says b raised to the log of x with base b is equal to x. So if the base of the exponent and the base of the log, if they're the same, then your answer is what you're taking the log of. So if you've got e to the natural log 2, I'm going to write it all out for you again. Remember, natural log is base e. That's an e there. And so that's 2. That's where the 2 comes from. And I plug natural log in to this function to get the y coordinate. All right, so we've got one more problem. This is the last one. It says the equation of motion of a particle is s equals 2t cubed minus 5t squared plus 3t plus 4, where s is measured in centimeters and t in seconds. Find the acceleration as a function of time. What is the acceleration after 2 seconds? All right, so we've got s. Let me change colors. So we've got s is equal to 2t cubed minus 5t squared plus 3t plus 4. there's my position function. All right. So I need to find the acceleration function. So the acceleration, which we learned earlier, and I think it was the last video, it's the second derivative. Okay, so if we take the derivative of the position function, that gives us the velocity, and then the derivative of the velocity gives us the acceleration, and that's what we're looking for, acceleration. So let's find the s prime, which is our velocity. I mean, I know it's not asking for velocity, but let's just label it velocity so we know that's what it is. So that's going to be 6t squared minus 10t plus 3. All right, so hopefully that made sense. Okay, that's just those power rules that we were doing before. And then the second derivative, which is the derivative of the velocity function, which is our acceleration. Well, that's the derivative of this function. That's 12t minus 10. And so our acceleration function is 12t minus 10. And, you know, if you want to, you can write a of t is equal to 12t minus 10. You know, actually, I think I prefer that. I mean, you can write it like this. Okay, so that answers the first part of the question. It says find the acceleration as a function of time. And then they want to know, what is the acceleration after 2 seconds? Well, we just evaluate the hang on, I hit something. All right, so all we're going to do is we're going to evaluate the acceleration function at 2 seconds. So that's going to be 12 times 2 minus 10. So that's 24 minus 10, which is 14. And then let's see. Remember, this is in centimeters and seconds. So that is centimeters per second squared. And there's your acceleration. All right. So this video, everything's important. Okay. But really, that this power rule, that's taking the derivative of x to a power. Okay, I'm not saying the other stuff is not important, it's all important, but this right here. And then of course the derivative of a constant term is 0. All right, there it is. You're learning how to take derivatives now. All right, get this down. Okay, and if you're just now doing this section, make sure you do all your homework before you go back to class to do the next section. All right, you get these next several sections, calculus is going to be a lot easier on you. If you don't, may not make it out. All right, so hopefully this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.